For more physics-related videos, please subscribe. Welcome to the Physics Almanac. In this video, we will cover motion under constant acceleration, which will lead us to projectile motion. And the great thing about constant acceleration is that there's only one equation. So I rated the physics level in this video as easiest. As I said, we only have one equation, and that is that the acceleration is constant. Now remember, the acceleration is a vector. It has a length or magnitude and points in some direction. In a previous video, I covered the three basic quantities of motion. The first one is the position, which is also a vector. It tells you how far away you are and in what direction. Then we have the velocity, which is the instantaneous time rate of change of the position, or the slope of the position on a position versus time graph. And finally, we have the acceleration, which is the instantaneous rate of change of the velocity, or the slope of the velocity on a velocity versus time graph. Since the velocity is the slope of the position and the acceleration is the slope of the velocity, this means that the acceleration is the second time derivative of the position, or the slope of the position. And this quantity is constant. Every other kinematics equation, which would be the velocity and position equations, can be derived from this. So let's recap position, velocity, and acceleration, and I'm going to do this in one dimension, assuming the acceleration is constant. I'm first going to draw three graphs, and on the horizontal axis for all three graphs, I'm going to put time. On the vertical axes, I'm going to put position, velocity, and acceleration. Now we're starting from a constant acceleration, so the acceleration graph is just a horizontal line. Let's say it's here. If this horizontal line is above the horizontal axis, then the acceleration is positive, and if it's below, it's negative. Now acceleration is the slope of the velocity, and as we said, it's constant. So to get the velocity, we just have to ask what kind of graph has a constant slope, and that would be a line. So if we take 2 points along this line, the change in vertical position would be the change in velocity, and the change in horizontal position would be the change in time. And rise over run gives you dv over dt. And as we can see here, if we use these grid lines to actually see what the slope is, dv, or the change in velocity, is going to be 1, 2, 3, 4 grid lines. And then dt is 2 grid lines, so dv over dt is 4 over 2, so that's 2. And we see we have an acceleration of 2. The general equation for a line will be that the velocity equals some initial velocity plus the slope times time. v naught is the velocity at time equals 0. If the acceleration is negative, meaning this line is down here, then the velocity will slope downwards instead of upwards. Now, the velocity is the slope of the position, or more accurately, the instantaneous slope of the position, or the time derivative of the position. So if the velocity is the slope of the position and the velocity has a constant slope, that means the velocity changes at a constant rate, then the slope of the position changes at a constant rate. So the position will be some curve whose slope changes at a constant rate. And it turns out that this curve is a parabola. And the most general equation for a parabola has the following form. Now, if you're familiar with calculus, you'll recognize that this is just the integral of this equation. If you're not, you might be wondering where this factor of 1/2 comes from. Well, it comes from taking an integral. So if you don't know calculus, you just have to remember that the position has a 1/2 in front of the term containing the acceleration. So we can now plot the position. It's a parabola. Where exactly this parabola is situated will depend on what the initial velocity is and what the initial position is. R0 is the position at time equals 0. If a is negative, then this parabola will be concave down instead of concave up. If you're finding this video helpful so far, please be sure to like and subscribe. Maybe share it with your classmates and friends. So I've been saying that the velocity is the slope of the position, but if you're not familiar with calculus, you might be wondering what does it mean to take the slope of a curve? Well, recall I said that it's not the slope, but the instantaneous slope. So that means that at some point on the curve, you draw a tangent line to that curve, and the slope at that point is the slope of that line. And since this is a parabola, that slope is not constant. It changes from one point to another. And the velocity at that point will equal the slope of that line. At the apex of the parabola, the line is horizontal. So at this point, the slope is 0, meaning the velocity is 0. So this point corresponds to the point where the velocity graph crosses the horizontal axis, the time axis. In this example, before this point, the velocity is negative, meaning the slope is negative, and afterwards, the slope is positive, so the velocity is positive. So now we can see that from our initial equation, acceleration equals constant, we can get the equations for the velocity and position. To get the velocity equation, you integrate the acceleration, and if you don't know what that means just means you take the area under the curve between 2 points. But you need to know your initial point, so that's where this initial velocity comes in. So this is an important concept here. The area under the acceleration curve between 2 points will equal the change in velocity. So if we were to take a look at these 2 points here, the change in velocity between this point and that point is just the vertical change. So that's 1, 2, 3, 4 grid lines. And if we go back to the acceleration graph, between those 2 points, which is between these 2 points, we have 2 grid lines vertically and 2 grid lines horizontally. 2 times 2 is 4. So the area under these 2 points, or under the acceleration curve between these 2 points, is equal to 4, which is equal to the change in velocity. And to go from velocity to position, it's the exact same thing. We integrate once again, which is where this 1/2 came from, and the area under the curve of the velocity will give you the change in position. And remember that if the area is beneath the time axis, then it's negative. So if you have a negative area, that corresponds to a negative change in position. So for example, let's say we take the area of this little triangle right here, starting at a velocity of 0. Well, the area of a triangle is 1/2 base times height. The base is 1 and the height is 2. So 1/2 times 1 times 2 is 1. Going over to the position graph, we started where the velocity is 0, which is the apex of this parabola, and we increased in time by 1 square. And our vertical change in this time has been to go from this point to that point, which is also 1 square. So we have a change in position of +1, which was the area under this curve here. So now we can go back, and simply from the fact that we have a constant acceleration, we can fill in the equations for the velocity and the position. And remember, these are vectors, which means you have an equation for each direction. We live in a 3-dimensional world, so each one of these vector equations is actually 3 equations. Now you'll notice that if I only have one equation, I need to know calculus to get the other 2. If you don't know calculus, then you just have to know 3 equations. If you do know calculus, then you only need one, and you can actually pick any of these 3 equations. If you know one of these 3, you can get the other 2 by either taking a derivative or integrating. Now we live in a 3-dimensional world, but let's take a look at 2-dimensional motion to make things a little simpler. And anyways, 2-dimensional motion is all we need for projectile motion. So in 2 dimensions, we have a horizontal component and a vertical component. So our complete set of equations, assuming constant acceleration, will be our 3 sets of equations for each direction. Now, ultimately, what we want is projectile motion, and we will take a look at that in the next video. So if you found this video interesting and would like to know more about projectile motion, please be sure to like and subscribe, and click the bell to be notified for the release of future videos. And if you have any questions, feel free to leave them in the comments. Thanks for watching, and I'll see you in the next one.